Hello, so today we will learn about recycle stream and bypass stream from the material balance course. So recycle stream is one where a portion of the outlet of a process unit is combined with a fresh feed and sent into the same unit again. As you can see from the figure, where the outlet, half a part of the outlet from the separation is bring back to the inlet and mixed with the fresh feed. For bypass stream is one where a portion of the inlet to a process is split from the feed, and instead of entering the process is combined with the outlet from that process. As you can see from the figure, there's a stream from the fresh feed split and went past the process, maybe a reactor or anything. It just passed the reactor and went into the outlet stream from the reactor or processor.
Okay, next, why bypass stream? First, it is to increase properties of the product, and second, to control a process variable. If a reaction releases a large amount of heat, then it will make the reactor hard and expensive to control. Thus, the concentration of the feed stream can be lowered by diluting the stream with a bypass stream. And the bypass stream acts as capacitance for heat transfer. Thus, it will make the temperature of the stream becomes lowered.
For example, for recycle, we have a question here. An evaporation crystallization process described below is used to obtain solid potassium sulfate from an aqueous solution of this salt. The fresh feed of the process contains 19.6 weight% potassium sulfate. The wet filter kit consists of solid potassium sulfate crystal and a 40% weight% potassium sulfate solution in a ratio 10 kg crystal per kilogram solution. The filtrate, also a 40% solution, is recycled to join the fresh feed of the water fed to the evaporator. 45% is evaporated. The evaporator has a maximum capacity of 175 kg water evaporated per second. Find the rate production of the crystal and the recycle ratio. So from the question, we can obtain the information as we underline here. So from the question, we can get the process flow diagram. After we draw the process flow diagram, we shall include the information that we get from the question, like here. And next, for the calculation, we can start by having the basis. So from the question, it stated that the evaporator has a maximum capacity of 175 kg water evaporated per second. So we can take that as our basis. And then from the process flow diagram, we can get overall mass balance, which mass flow rate in equals to mass flow rate out. So from the process flow diagram, we can get M1 equals to 175 plus with 11 M2. So from the equation, we can also get from the potassium sulfate balance, we can get the equation of 0.196 m1 equals to 10 m2 plus with 0.4 m2. So from the overall equation and potassium sulfate equation, we can get m2, which is equals to 4.1606 kilogram per second. So from the with m2, we can get the production rate of K2SO4 solid, which is 10 times with m2 equals to 41.606 kilogram per second. So from that we get the answer of production rate for the crystal. Next, for the recycle ratio, we can start our calculation with finding the value of m1. From the equation, m1 equals to 175 plus with 11 m2. So we can take the value of m2 that we obtained from the last equation, which we get m1 equals to 220.7667 kilogram per second. From that, after that, we need to get the value of m5, because from the process flow diagram we can see that the recycle ratio is m3 divided by m1. So in order to find m3, we can get from the equation the balance of H2O at mixing point, which is 0.804 m1 plus with 0.6 m3 equals to m5. So we have m1, we want to find m3, but we don't have m5. So we can obtain m5 from the 45% evaporated, which is 0.5 m5 equals to 175. So from that we can get m5 equals to 388.8889 kilogram per second. So with the m5 and the m1 that we already have, we substitute in the equation, and we get m3 equals to 352.3208 kilogram per second. So from that we can get recycle ratio, which m3 divided by m1 equals to 1.5959, approximately is 1.6.
This is an example for a bypass stream question. It's written, in an ethanol plant, a separator is used to recover 99% of ethanol product. The separator has two outlet streams, the ethanol product stream and a residual water stream. A portion of the feedstock to the process is bypassed to be mixed with residual water stream leaving the separator. The feed stream is 85% water and 50 ethanol by weight and flows at a rate of 550 pounds per minute. And then 13% of the feedstock is bypassed. The separator is 60% of the original feed. The composition of the residual water stream right after leaving the separator and right after the mixing point of the bypass stream. So the question wants us to find the composition of the residual water stream right after leaving the separator, and second one right after the mixing point of the bypass stream. So this is a flow diagram for this question. Now it's time to calculate. Since in the question it stated that 30% of feedstock, 30% of the feedstock is bypassed. So from here we can find flow rate of M3. We can find the value of M3 by substitute the value of M1. So 0.3 is from the 30% of the feedstock times 450 pounds per minute. So M3 value is 135 pounds per minute. 135 pounds per minute. Okay. Since we know the value of M3 and M1, next step we can find the value of M2. The value of M2 is here. Okay. The value of M2, we subtract the value of M1 minus M3, 450 per minute minus 100 and pound per minute. So the value of M2 is 150 per minute. Okay. The value for bypass split SW1, W indicate for water and E indicate for ethanol. SW1 equals to SW2 equals to SW3. So the value for this is 0.85, and E indicate of ethanol SE1 equals to SE2 and equals to SE3. So the value for SE1, SE2 and SE3 is 0.15. Okay. From the question stated that 60% the separator removes 60% of the ethanol originally sent in the feedstock. So from the 60% recovery of ethanol, we can find the value of M4. Here, M4 for the product. Since M1 SE1 equals to M4 SW4 and SE4. No. M1 Xe1 equals to M4 Xe4. Okay. Since we want to find the value of M4, 0.6 here is from 6% the recovery of ethanol. Okay, 0.6 times 450 pound per minute and times the value of Xe1. Oh no. Xe1 divide by 0.99, which is the value of Xe4. So the value for M4 is 40.9 pound per minute. I forgot pound per minute. Okay. Okay, now we have the value of M1, M3, M2, and M4. For overall mass balance, M1 equals to M4 plus M6. To get the value of M6, it is equals to 450 pound per minute minus 40.9. So the value of M6 is 409.1 pound per minute. M6 is here, residual water. For separator mass balance, M2 equals to M4 plus M5. So the value of M5 is 274.1. Here, M5 274.1. Okay, now we got all the value of M1, M2, M3, M4, M5, and M6. Next, we need to find a separator water balance. Okay. M2, since we need to find XW5 here, so the equation is M2 XW2 equals to the product M4 XW4 plus M5 XW5. So rearrange the equation and substitute the value. We will get the value of XW5 is 0.97. Okay. Since XW5 is 0.97, to get the value of ethanol, just subtract 1 minus 0.97. So the value of ethanol is 0.03. And lastly, for overall water balance, this is the equation to find the residual water. M1 XW1 equals to M4 XW4 plus M6 SW6. Here, if you want to see the diagram. Okay, we want to find the residual water here, right? So, we use the equation of M1 XW1 equals to the product M4 XW4 plus M6 XW6. Okay, substitute the value and rearrange the equation. We will get the value of XW6 equals to 0.93. And the same as before, to find the value of ethanol XE6, just subtract 1 minus 0.93. So the value of XE6 is 0.07. Okay, that's all. Thank you.